Yeah, let me control that. Okay. Good evening, everyone, and welcome to this um, special talk series being organized by NPTEL. Um, I'm going to talk about the semiconductor and electronics industry a little bit, talk about uh, the evolution, and spend a little bit more time about the current state of the technology and what to expect in the future. The talk's about for an hour. We'll have a presentation for about 45 minutes or so, and then we'll spend the last 15 odd minutes trying to respond to the questions that you have. There is a Google Sheets link in the chat box. Please enter your questions there so that when it comes to Q&A time, I'll try to respond to as many of the questions as uh, as I can. So with that, I am going to bring up my presentation here. Just give me a minute. Um, okay, hopefully you can all see my slides. So I will go ahead and get started. This is the agenda that we have for today. I am going to briefly introduce myself and Cadence Design Systems, the company that I work for. Talk to you a little bit about what EDA is all about. That's the industry that we are a part of. But then spend a little bit more time talking about global trends in the electronics industry. Introduce the concept of pervasive intelligence, which is a key driver for the industry. And finally, I'll segue a little bit to talk about opportunities in this industry in India. Um, I have been part of this industry for over 31 years. I'm coming up to 32 years in the industry in the month of July. As you can see, I have a bachelor's in electronics engineering and a master's in computer engineering. I've had a ringside view of the EDA and semiconductor industry in India. I joined the industry right from the beginning, so I've had a ringside view for how the industry has evolved over that period of time, what some of the highs and lows have been, and I'll share a few of those along the way. But as I said, the focus will be a lot more on what lies ahead. About Cadence Design Systems, the company was formed through the merger of two companies, SDS Systems and ECAD, in 1988, and that's also the year that I joined the industry. And so you can pretty much treat the mid 80s as the time frame when the EDA industry was born. So we've been around for 32 odd years. Cadence has over 8,100 employees worldwide. We are present in 22 countries. And what we really pride ourselves on, which I think has been the key to our success over that period of time, has been our culture, which is focused on innovation, exceeding customer expectations, intense focus on executing with quality, and constantly elevating our team. And you see that on the bottom right hand of this slide. Some facts and figures out of that 8,100 employees that we have worldwide, 5,100 or so are core R&D engineers. Most of these are from a software background. We have about 1,800 field engineers. These are folks that work with our customers to help them use our tools successfully. So these are all people with design background. We have over 1,500 patents worldwide, many of them from our team here in India, and 26 global development centers, four of them being in India, which is in Noida, Bangalore, Pune, and Ahmedabad. In India, our operation started in 1987 with an R&D center in Noida. It was by a company called Gateway Design Automation. That's where I started. In 1989, Cadence acquired Gateway, and so we've been a part of Cadence since 1989. And today, our sites in India are the largest outside of our corporate headquarters in San Jose. Our second largest site worldwide is in Noida, and our third largest site worldwide is in Bangalore. We have a full range of functions. As you see, there's more details given here. I won't walk you through them. What's interesting to many of you on this call is that we have a very active university program with over 350 engineering colleges across the country that have access to our tools and have incorporated them to various degrees within the curriculum, either at the undergraduate level or at the graduate level. And we also have a very vibrant academic community on this platform called cadenceacademicnetwork.com. This is more of a global community. So if you want more information, you're welcome to check that out and go there. Um, I will not go through much more details about Cadence. I will stop at that point in time. But if you're interested in learning more about Cadence's journey in India, there is this reference. There was an article, a series of articles that EE Times Europe carried in their February issue, and the link is given. Please feel free to go to that link after this talk and take a look. One is an article authored by me, which is more on the Cadence India journey, and there is another article authored by a friend of mine, Nitin Dahad, which talks about India's chip industry over a period of time and how it has evolved. So with that, let me dive into a very brief introduction to what EDA is all about. EDA, which is the business we are in, it's really software, tools, and IP that's used by designers that are designing chips, packages, and boards, right? Which are the different pieces that go into any electronics system. So we are a company that's in the business of EDA and IP. IP standing for intellectual property. Now, intellectual property here has nothing to do with patents and things like that. Of course, as I already said, we have over 1,500 patents as a company. This really is blocks of design that are reused in a bigger design. So you can think of a processor core, for example, as a piece of high value intellectual property that gets used into a system on a chip or a bigger chip that may get designed. So from an EDA standpoint, we bifurcate things into two broad buckets. One is the integrated circuit or the semiconductor chips, and the other is the printed circuit board. And we are one of the few companies, perhaps the only company in the world, which has a comprehensive portfolio of products that addresses both these domains of EDA. What's been a key driver for us, right? What's the heartbeat of this industry? It goes back to what's now come to be known as Moore's law. In 1979, Gordon Moore, one of the founders of Intel, said the number of transistors incorporated into a chip will exponentially double every 24 months, right? There's very few industries that can claim that kind of rapid progress and progression, but this has been the heartbeat of the semiconductor and the electronics industry for the last 50 odd years. And it's reflected so wonderfully into the processor roadmap that comes from Intel itself. If you look at the Intel processors from 1970 all the way up until the more recent times, you'll see that the number of transistors that is there in any given processor has been doubling very rapidly, while the cost of those processors has been coming down. And that is actually one of the more interesting drivers of the industry, which is the inverse Moore's law. It's really driven the semiconductor industry. And it says that while the number of transistors on a given area of silicon may double every 2 years or so, in reality, it's been doubling every 18 months or so. The cost of implementing any functionality in silicon halves every 2 years. And that's a very profound thing. And if you think about it, the cost drops by a factor of 30 in 10 years. In 25 years, over a period of 25 years, something that used to cost $1 million 25 years ago would cost $200 or less today. And the best proof point of that is an average smartphone that most of us carry. The smartphone, which price point ranges between $200 to $500, packs more transistors and more functionality and more power and more performance than a mainframe computer did when I was going to college. And so that's the most wonderful thing that that's been driving this industry. A multi-million dollar flight simulator of the 80s today costs $250 because you have more capability with better graphics and so on and so forth in the average game console that's being sold today. So it's been a wonderful journey over that period of time, and it would not be unfair to say that the largest and most profound impact on mankind has come from progress in electronics that has been enabled by semiconductors. And if you think of where we fit in Cadence as a company, we are the enablers of semiconductors. So it's very heartening for us to have been part of this journey for this industry and the impact that it's had on mankind. And I see no reason why that will not continue for many, many years into the future. Now, talking about the underlying semiconductor processes themselves, I remember very distinctly when I joined the industry. At that point in time, the state of the art was 5 micron technology, right? 5 microns. Today, we are talking about production at 7 nanometer technology. Production chips are being designed and manufactured at 7 nanometers. But I know that some of the leading foundries in the world are actively working on processes at 5, 3, and 1.5 nanometer technology. So, people have been saying that the semiconductor scaling will end at some point in time. We've heard about the death of Moore's Law for the last 10 to 15 years, but Moore's Law is alive and well. Yes, the economics of this scaling are a key driver to what applications will justify the move to some of these more advanced process technology nodes, but the industry is alive and well, and Moore's law is alive and well. Let's take a look at some of the global trends that are driving electronics today. And the most profound of these trends is around data. As you can imagine, right, we talk about the era of the data-driven economy. People use phrases like data is the new oil, many different things that you hear. But what's happening is because of the very rapid progress and proliferation of various devices with sensors attached to them, specifically things like IoT, we are generating very, very large quantities of unstructured data, right? If you think about various kinds of IoT devices, there are projections that say that by the year 2025, there could be over 50 billion 50 billion IoT devices, and that's on the very, very conservative end of the spectrum. So people talk about between 50 billion to a trillion IoT devices. Even if you look at it at the most conservative end of 50 billion IoT devices, that on the average means that for every living person on this planet, there's at least 7 to 8 IoT devices that are generating streams of data. That could be temperature sensors, these could be cameras, this could be various kinds of voice recording devices. The list goes on, right? This could be connected devices from the industry, this could be automobiles, so on and so forth. So we are generating huge quantities of data. I mean, people are talking about the fact that we as a human race have generated more data in the last 2 years than in the entire existence of mankind before that. And the rate at which we will generate data will only go up in times to come. So if you're generating all these vast quantities of data, what are we going to do with this data? Well, we need to first of all have a way to store this data that is driving rapid progress in various kinds of storage technologies. We are going to have to transmit that data somewhere, either whether it's transmitting for storage or transmitting for processing. So that's driving in progress in various kinds of wireless and wired communications infrastructure. And then, of course, we have to process this data. And where are we going to process this data? We could be processing this data in large data centers in the cloud. We could be processing this data in other servers, or we could be processing this data at the edge where the data is generated. So a lot of different applications and devices are coming up because we are creating this immense amounts of data. Now, this data is largely unstructured data. So the conventional ways where we've got structured data and we've got structured programming that can analyze that data, those are breaking down, and that's creating a lot of momentum behind the use of AI or machine learning, because that is the only way to make sense of this data. The data is so large that traditional analysis ways won't work. So we are really now looking at finding patterns and making sense of this data by looking for patterns in this data. So we are creating a virtuous cycle which is driven by this phenomenon of amazing amounts of data that's being generated. Now, what are some of the other things that are going to drive, at least in the foreseeable future, right? If you look at the next 5 years, maybe a little bit longer, a large quantity of this data is going to get generated by smartphones that each one of us use. Um, we are talking about autonomous driving, but it's not just autonomous driving, it's also advanced driver assist systems and a lot of the other things that go with it. And of course, the Industry 4.0 revolution that's happening. Now, Industry 4.0 is a very interesting use case because for a lot of the other technologies, it's a very controlled environment, right? It's a controlled environment where you can have autonomous vehicles moving around, various kinds of other technologies that you can experiment with. Now, the large quantities of data that are going to get generated, again, to be able to transmit them, it's driving the 5G technologies that we hear a lot about. And then, of course, investments in the cloud and data centers. But a large amount of processing will also happen at the edge. The things that you see on your right-hand side, be it the smartphone, so a large amount of the data that we create, fair amount of the processing happens at within the smartphone. For example, face detection, voice recognition. When you are using one of the music apps and you are speaking to your phone and asking it to find a certain track from one of the cloud music services, a large amount of that processing happens in the smartphone before an instruction goes at the back end to the service provider to be able to stream back that music to you. In terms of the autonomous driving cars that are not yet in mass production, but a lot of technological progress that's being done. A lot of the decision making that has to happen becomes very timing sensitive. Now, if a car is getting a signal that there's an obstruction in front of it, and you have to recognize the nature of the obstruction and make a decision whether you want to go left or right or brake, that decision has to be made in milliseconds, in nanoseconds, right? The response time becomes very important. So because of considerations of latency, that decision has to be made at the edge, which means within the car, and you don't have the luxury of transmitting that data, you even using 5G into some kind of a data center in the cloud to be able to process that data and give you instructions back that, okay, you need to brake the car, or the car needs to brake itself, for example. So a fair amount of processing is going to happen at the edge. So if you were to sum it up, what are some of the key industry trends that are driving growth in the electronics industry, and as a result are creating a lot of opportunities for new kinds of chips to be created? It is around the entire 5G technology. It's around automotive, and automotive here is not just cars, but all kinds of autonomous kind of vehicles. It could be drones. It could be other kinds of goods carriers, robots that are in warehouses, and so on and so forth. Of course, investments in clouds and data center, and Industry 4.0, uh, driven with a big focus on machine learning. And interesting thing there is that if you look back historically, we've had maybe less than a dozen different processor architectures that have existed. Of course, we all know about the x86 based processor architectures that come from Intel. We've had PowerPC, we've had MIPS, we've got the ARM processor, we've got a few others, but less than a dozen. With the advent of machine learning, and with the need for it to process very specific kinds of streams of data, there are a very large number of startups across the world that are coming up with novel architectures targeted for specific AI and machine learning applications. So on the last count, somebody mentioned there were over 150 startups doing unique processor architectures for different kinds of applications. So a lot of excitement, a lot of opportunity at this point in time in the broader electronics and semiconductor industry. We've already talked about Moore's law very briefly, but as I said, it's alive and well, and you can see there's a roadmap here that goes all the way into 2030 and maybe even beyond. And there are various kinds of things that have driven the fact that the Moore's law remains alive. In the early days and up until recently, it was lithography, novel materials, different kinds of device architectures. By device architectures, we've talked about things like FinFET and things that came up in the last 5, 7 years. Um, in the future, it's about a co-optimization of design and the underlying process technology. And going forward into the future, even it's going to be a co-optimization of system and underlying technology. And that system is an important vector beyond Moore's law because while Moore's law is one key vector that's kept this industry moving forward and made things better, smarter, smaller, and cheaper. At some point, it's fair to assume that that scaling may not be viable. As you see in this roadmap, it goes to 3 nanometer, but we know it's going to go up to 1.5 or 1 nanometer. And then more novel compute methods like neuromorphic computing or quantum computing, which are in research, will come into production sometime in the next 10 years or so. So we've had an exciting run, but a very interesting trend that's been developing over the last uh, 5 to 10 years is what's called more than more. So it's not just about semiconductor process scaling, but it's about heterogeneous uh, substrates coming together. Things like system and package or module based design or 3D IC, using silicon as a substrate to integrate different kinds of technologies. As you see the little graphic on the in the top right hand corner, right, it's really a 3D kind of a view for the chip. And what it does is it gives us the capability that if the digital portion of the chip can benefit from the scaling and can be done at 7 or 5 nanometer, whereas the analog portion of the chip can be maybe at 28 nanometers, and we can put some MEMS and sensors all into a single package and create all kinds of new and interesting applications. You might have heard for lab on chip, which is a medical diagnostic technology which blends mechanical, chemical, and semiconductor technologies all together to create, again, very cost effective and interesting solutions for problems that otherwise have traditional solutions that are very expensive and wouldn't scale into the future and would have long turnaround time. So a lot of exciting opportunities leveraging these different technologies. Now, what is pervasive intelligence all about? Right. This, as I mentioned earlier, it's a key driver for the industry. There's a lot of exciting things that are enabled by virtue of pervasive intelligence. So, what is it all about? What it's all about is, again, the fact that the architecture of electronics in general is evolving. Right. In the past, uh, when we talked about computation or intelligence, you can replace it with computation, which means there's a processor in there. In the past, that was in a server in a data center, it's in your laptop or desktop computers, and it's in your smartphone. And there were very few other applications that had significant amounts of compute capability, right, or ability to process data. And what's happening now is that through a range of applications that are emerging, there are many more applications that will have both the need and the opportunity to process the data. If you look at autonomous vehicles and systems, and I talked about it a little bit earlier, it's the autonomous cars, trucks, it's mining equipment, it's drones, it's robots, it's personal assistants of all kind. It's a lot of the other applications that are there. They are constantly, they have large number of sensors that are sensing their environment, that are generating a large amount of data. They are processing that data and making decisions in real time in terms of how to navigate those environments. And so drones and other kinds of mining equipment, which are in very hazardous or hard to reach areas, very interesting applications and a lot of research and progress happening in that area. Then there is the whole paradigm of various kinds of intelligent edge or smart edge devices backed up by stuff in the cloud, right? So predictive maintenance of various kinds, embedded electronics in various things that are sensing. For example, you could, have sensors in the tracks of a railway line that are able to look at the vibrations and determine if there is potentially some breakdown that might happen in the railway tracks and you want to do some preventive maintenance. That's just one example. You can do that same thing for the trains themselves, the wheels, the engines, the bogies, etc. So again, very large number of possible applications for predictive maintenance, video surveillance, medical diagnostic, coupled with things like augmented reality. So large number of applications, real-time data processing, a very, very broad class of what are called intelligent edge devices that are coming up, some in development, some in production, but a lot of opportunity in this area. And then of course the intelligent networks and mobile devices connected to that. And 5G really is a game changer. So if you think about it, large numbers of sensor based intelligent devices at the edge coupled with 5G to transmit data with very large quantities of data with very high bandwidth, very low latency, and then huge investments at the back end in cloud and data center are making a whole new class of uh, applications possible that we could barely even imagine until, let's say, 3 to 5 years ago. And so, what does that mean from the compute architecture of these devices, right? So, typically, any device that we can think of, any of these intelligent devices, intelligent systems, will have three broad components, right? There will be obviously sensors that are capturing the data. There will be some kind of data processing unit, because you've got either big data that's coming in through some source like temperature sensors or pressure sensors and things like that, or there could be cameras or vision sensing that's capture and sensing that's happening, or there could be some microphones and speech or other kinds of audio signals that are being captured. These have to be processed in real time. You got to make some sense out of them. Then based on that you've got to make some decisions. What do I do? Is there some kind of a response that's warranted, and so on and so forth. There might be some actuators that do the response, and there might be need from time to time either continuously or intermittently transmit that data up somewhere else to aggregate the data from multiple of these sources to make decisions, do some analysis and decisions in an aggregated manner. So connectivity becomes very important. So any such system will have at least broadly three different aspects to it: data processing, decision and control, and connectivity. And this is driving a transformation in our industry, EDA, right? As I told you earlier, we are part of the EDA industry, but that is evolving, that is transforming in a big way. And the key drivers again for this transformation are explosion of data and AI computational needs. Both create systems that leverage AI to compute this unstructured data in various kinds of real time, but then also to use that data to make those systems themselves better over a period of time. The more than more type uh, driver for overall systems coming together with sensors and actuators and various other kinds of things, along with an increasing amount of software that's part of electronic systems. So the need for us to do hardware and software co-design, the fact that when you are packaging so many different things into a system, right, there are various kinds of unintended consequences that are possible that could be around things like, thermal profile or the heat dissipation that the system does, and our need to analyze the thermal profile to make sure that the system doesn't break down in the field because of overheating or hotspots that may exist. The electromagnetic interference that may um, impact the performance of the system over a period of time. So multi-physics analysis becomes very important. And of course, the exponential growing cost and complexity of silicon design itself as it goes from 7 nanometers, 10 to 7 to 5 to 3, etc. Because each one of these process nodes has an implication on the complexity and cost of design. So this is driving a kind of convergence in the computational software, which is a core competency for us. resulting in what we refer to as intelligent system design. So all these paradigms have to come together now and going into the future for us to be able to continue the progress that's possible by the semiconductor and the electronics industry in general. So, quick segue into sort of the opportunities in India. Clearly, as I said, if you look at it from an India perspective, this is potentially a $400 billion market. Few years ago, when I was the chairman of the India Electronics and Semiconductor Association, we did a bunch of studies and we approached the government of India to say, think about the economic consequences of not investing in the semiconductor and electronics ecosystem because it's possible that we could have a balance of payments crisis because our import bill on electronics could be more than the import bill on oil by the year 2025. Of course, that might have already happened more recently, given the fact that because of this lockdown, nobody is driving, so our oil imports are at an all-time low. But really, under normal circumstances, also by 2025, that dynamic is likely to change. Um, for many of you who will be graduating in the next couple of years, I'm sure you're thinking of what are the opportunities for me in India. There's a couple of different vectors to look at. One, of course, there's a very large number of global semiconductor companies that are present in India. This is a very short list. You can always go to the India Electronics and Semiconductor Association website and see who are the different companies that are present there, and a lot of opportunity for many young designers in many of these companies. But what's really interesting is that there is tremendous opportunity for entrepreneurship also. One of the proposals we had made to the government was that, to bootstrap the entrepreneurial uh, culture in India, we need to invest in creating various kinds of incubators and accelerators. And I'm pleased to tell you today that there is several of these incubators and accelerators that are available for aspiring entrepreneurs, and they really lower the barriers to entry because they provide you with a lot of infrastructure and a low risk way of experimenting and trying out your ideas. So if you have a killer idea that you passionately believe in, there's a lot of opportunities for you to experiment with those ideas and develop them into business plans for products going forward. And if you think about it, in India, we have many, many unsolved problems as a country, right? We don't really have to look out to the West. There are certain areas where large global corporations are investing to find solutions, and in those areas, it'll be hard for us as entrepreneurs to compete head on with them. But if you look at in our own backyard, there is a large number of problems. And the good part is, in this case, a problem really is an opportunity that's looking for a solution. So if we can find a problem that's worth solving and have an innovative, creative way of solving that problem, then there is fascinating opportunities that exist. And just to give you a brief preview into some of the real problems that we are facing as a country to which we need more solutions is first, clean drinking water, right? Large parts of the country, maybe depending on whose statistics you believe in, anywhere from you know 10 to 50% of India's population doesn't have access to clean drinking water. And definitely this is a problem that's only getting worse because of groundwater contamination and pollution of rivers and so on and so forth. As we grow as a country, as we have more urbanization, energy becomes a big challenge, right? I mean, we need access to energy to drive industrialization, to drive urbanization, but we need to have access to energy in a responsible manner. So the focus on renewable energy, smart energy, energy conservation, there's a lots of different ways to address that and solve that. Waste management is a big problem, and specifically e-waste management, but waste management in general, solid waste management, and how we can approach it from a waste to wealth perspective, right? Harness what's there and then see how we can reuse or recycle some of the waste. Security is definitely a problem that or a challenge that we face as a country. Education, and I don't just mean education for those who have access to education conveniently by being, number of number of universities, colleges, schools, good quality universities, college schools that we have in the country are still limited, and the number of young children in the country who need education is much larger. So how can we use technology? And this lockdown period has actually helped us explore alternatives and make some progress in that area. But how to leverage technology to have affordable access to education to very large numbers of India's youth is a huge challenge that needs to be addressed. As we drive for more urbanization, urban mobility, right? I mean, public transportation infrastructure is not what it needs to be, but we need a next generation urban mobility solution for the country, and that needs to be built on electric vehicles. And that in itself comes up with lots of downstream challenges. And of course, healthcare and medical electronics in general is another big area. Because if you look at, we've got some good hospitals in the large cities, but as you go into the vast parts of the countryside, access to healthcare is limited. And so again, how to leverage technology and focus on affordability of healthcare. Now, solutions that are available in the West don't necessarily scale and apply to India because of uh, environmental factors within which they need to operate, as well as affordability considerations. So we need innovative solutions. And I'm going to share a couple of interesting examples of how some of these problems are being solved. So on clean drinking water, I'm sure you've heard of the famous water ATM, right? I mean, that's an innovative solution that people came up with, and it leverages electronics at the heart of it. But really, it makes clean water available to at a very affordable rate. Um, we talk about access to energy or electricity in large parts of the rural parts of India. One of the challenges is how do we extend the grid supply to the very vast part of the country. So if we can have a standalone solar power systems with technology to enable local entrepreneurs to manage it on a community basis. And there's a very innovative startup as part of the Electropreneur Park in Delhi that called Durastha that came up with a solution for something like that. Um, Blending education and security, right? I mean, you've heard of some of the horror stories around what happens in some of the schools with child molestation or abduction and things like that. But the classical tracking of kids inside a school building, because of the way schools are constructed, you need some innovative ways of ensuring that you can map the movement. And there's another very interesting startup in the Electropreneur Park in Delhi that has a solution for that. When it comes to urban mobility, of course, the world is focused on the Teslas and the high-end the high-end electric cars, but India also needs e-rickshaws, for example, right, which is a key part of the urban mobility infrastructure, especially for last mile connectivity. If you look at things like the metro that might be coming up in various cities, one of the big challenges that e-rickshaws face is charging infrastructure, because they're using conventional batteries, and they need to charge overnight so that they can run it for about 7 8 hours, but then their day is gone. So if you can have fast charging, intelligent fast charging that ensures the pay-per-use kind of business models. And again, there's another very interesting startup as part of the Electropreneur Park in Delhi that's solving this problem. So uh, point being that there are interesting problems that require interesting solutions for the Indian environment, and we have an opportunity to live it and observe it firsthand. So there is nobody better than us to find solutions to these kinds of problems. So solve real world problems with innovative solutions, problems that are all around you, that you are in the best position to observe. And there's nobody else in the world outside of India that's even paying attention to many of these problems. So we are uniquely positioned to address some of these problems. Uh, a couple of years ago, I gave a talk at an event called Avahan 2018. This talk is available on YouTube. I speak to some of these things that I've spoken about in the last couple of minutes, and I go into a little bit more detail. So if you're interested in exploring that topic and learning a little bit more about it, please feel free to go to this link on YouTube and listen to the talk. Hopefully that will stimulate your own thought process and motivate you to explore those options. So with that, I'll try to wrap up my presentation and then get into the Q&A part. And really, it's the business leaders of tomorrow will be those who solve real-world problems in a scalable, profitable, and sustainable manner. And I think each one of us has a wonderful opportunity to do that. India is one of the fastest growing electronic markets in the world. It's a $400 billion opportunity, as I said. And today we are importing a large part of that electronics, but going forward, we have an opportunity to design and make in India, both for India and for the world. There is a huge opportunity, a huge potential opportunity in the so-called bottom of the pyramid. 600 to 700 million people in India who are below a certain income threshold that the rest of the global players are not focused on, right? They are focused on what they define as the middle class. That's a certain income band that is maybe about 300 odd million people in the world, in India. So there's about another 600 odd million people in India that they're not focused on, that are not in the BPL category or below the poverty line category. So they have unmet needs. And there's a lot of opportunity for us to find solutions for these. And of course, I believe that there are companies that are building profitable business addressing these problems. So I'm excited about the opportunities of building profitable, sustainable, responsible businesses in that. With that, I'll wrap up my prepared slides. And if you have any questions, please feel free to write to this email address, and we'll try to see if we can respond to those questions. And that's referring to questions that I'm unable to answer today, or if you have follow-on questions to some of what I have shared and presented today, please don't hesitate and write to that email address, and we'll make sure that myself, or somebody from Cadence will get back to you with a response. So with that, I am going to very quickly now switch over and try to get to some of the questions that you've been asking on the Google Sheets link that was provided. So if you have not entered your questions, please do enter. And for the next 15 minutes or so, I will try to address as many questions as I can. It's great to see there are already something like 77 questions. So I know already that there's no way I can respond to 77 questions, but I'll try to respond to as many of them as I can. Give me a moment to scan these questions. So first interesting question I see here is from Sravan from Chennai. And Shravan asks how to start preparing for a career in digital design for roles like verification for a student who has been taught only basics of VLSI and has gone through few labs using Verilog. Basically, what are the skill sets required for such verification engineers? Great question, Stravanan. Verilog hardware description language is just, it's one of the prerequisites for a career in front-end design or verification, both. So the good news is that you've taken the first step on that journey. Um, the best way I know is if you really want to prepare, if you have clarity in your mind that you want to pursue a career in verification engineering, then I would encourage you to try to get an internship in one of the many companies that I listed, or many of the other companies that do design and verification in India. Reach out to one of them for an internship. That's the best way to get a little bit more hands-on exposure to the entire verification paradigm, because there's a lot more to complete verification, because verification includes the traditional simulation, but there is metrics driven verification. There is the use of formal techniques for verification. There is the use of emulation or hardware based verification. There's a lot of different aspects to verification, and the best way to get that experience and exposure would be through some sort of an internship, or reach out to one of the verification engineers, leverage LinkedIn or something, and reach out or connect to one of the verification engineers in the industry. And I'm sure on a one-on-one basis, they'll be able to guide you on some project that you might want to pick up, leveraging the infrastructure that exists in your university. But I'm glad to see that you're thinking ahead of how to build a career in an area that you seem to have some excitement and passion around. Okay. Another question here from Shashank. This is from Mangaluru in Karnataka. Will high-level synthesis tools and System C replace HDLs, or hardware description languages? And honestly, the short answer to that question, Shashank, is that no, I think these two things are complementary. If you think about it, hardware description languages work up to a certain level of abstraction, which is RTL or register transfer level. So it's RTLs through gate level are the levels of abstraction at which hardware description languages work. And traditional synthesis, verification, etc., using HDLs operate in that zone. What high-level synthesis tools and System C attempt to do is to raise the level of abstraction further up. So in that sense, they are complementary. And high-level synthesis tools and System C will generate outputs that will then connect to tools that operate in the HDL space. So no, they won't replace them, but these tools and technologies will be complementary to each other and at a level of abstraction that is higher up. Okay, another interesting question here is from Vaibhav Gupta from Varanasi in UP. And he says, can you please tell various job profiles available and their future scope for freshers with masters in VLSI design? And again, Vaibhav, I think there is a very vast field. As I mentioned, there's a very large number of both multinational companies that have significant design centers in India, as well as there are Indian companies, startups, design services companies. There are various kinds of defense research labs, SCL, ISRO, Space Application Center, DRDO, etc. So there is a large number of companies in various sectors that are doing various kinds of design and verification. And your typical careers would depend on if you want to be in the front end space with verification, leveraging things like HDLs, or in front end design or physical design. Do you want to be in, if you are more core engineering, then you're looking at things like analog design or digital design. So broadly, I mean, there's lots of different areas within which you can play, and it depends on what really your passion is. And again, a great way is to dip your toes through some sort of an internship to get an understanding of different domains, and then choose which you are most passionate about, and then pursue that. But bottom line, there is tremendous opportunity in this field. Okay, Ganesh Shalke from Aurangabad. The question is, if a new startup wants to start the manufacturing plant with some SMT pick and place machines with the oven and soldering facility which doesn't have its own product but can manufacture for others, what is the opportunity? Okay. Um, first of all, I think there are other plants like this, and the real dependency in terms of the opportunity will be how the product ecosystem in India develops, and how many more companies come forward that are designing products that need to access to electronics manufacturing. So, these parts of the ecosystem, which is design and manufacturing, need to go hand in hand. And we've always believed that the right way forward for India, not to compare with what might have happened in China or Taiwan or Korea or Israel, but for India, the right way forward is what we call design-led manufacturing. And it's really in the design part, which is a core competency for India as a country, where core intellectual property gets created, which is the real value of an end product. So if anybody is starting something, my strong recommendation would be to think of that design-led manufacturing as a paradigm. And of course, there'll be companies that will only do design and some that will do manufacturing. So really the opportunity depends on how quickly the product and design ecosystem in India develops. It is developing, it's at a somewhat nascent stage, but it is developing. So definitely that is something that's worth exploring. Uh, let's see, next question. Shivani from, I think this might be a typo, I think it's from Manipur if I'm not mistaken. And the question is VLSI going on a downfall? Oh, wow. Uh, Shivani, the very short and crisp answer to that is an unequivocal no. The VLSI industry is alive and kicking and going very strong. And I'm talking about it from a worldwide point of view. And the reason I say that, and hopefully my talk earlier gave you a sense for what the industry is enabling and the future opportunities. But if you think about it, right, a large amount of the progress that we've seen in our quality of our lives over the last 10, 20, 30 years has been enabled by electronics. Look around you, right? What are the things that have made your life better? And it is technology. It's technology. You may say certain software applications, but those run on hardware, and the hardware is electronics, and at the heart of that is semiconductors. So uh, a large amount of the progress is enabled by electronics, and that is enabled. The key driver for that is design. And even if end product demand may go through cycles, there will be highs and lows, and some end products may no longer have demand. There are other end products that will go through a boom phase and have a lot of demand. But when it comes to design, no matter how their business is going, most companies continue to invest in designs because that is going to be the differentiator no matter what economic cycle they are going through. And even in economic down cycles, we've observed over the period of time that most companies continue to invest in product innovation and coming up with next generation of products so that when the economy does recover, and it always does recover, at that point in time, they are well positioned to serve the needs of their customers and to differentiate against their competition. So, on the design side, we've seen that through all the highs and lows of the economy, the design side has remained very, very strong and vibrant. Okay, let's see. Man, there's so many questions. I think there's a fair amount of questions on the future of the VLSI industry. There's an interesting question here. I think Ankush from Bangalore is asking, due to COVID-19 situation, how the market will move for freshers hiring. So, Ankush, it really does depend on the industry segment that you're a part of. The good news is that a large number of the solutions that are helping us through the COVID-19 situation are based on increased use of technology products and solutions. Even, this platform that we have right here leverages technology in many different ways. So investments in technology will continue, and in fact, even through all the downturn with the lockdowns all across the world, it is those of us who are working in the technology sector that have continued to work very effectively from home because the nature of our jobs allows us to work remotely from home, and the technology infrastructure enables us to do it. So think of it from that point of view, that if you are in the technology space, that's a good place to be. And the opportunity for technology, while there'll be a few glitches here and there, and there'll be some sectors of the broader technology industry that might see ups and downs, but more broadly speaking, the technology industry is a great industry to be a part of, and especially through the COVID-19 situation and coming out of it, investments in technology will go up, and as a result, I foresee that uh, opportunities in the technology industry will remain strong going forward. Okay, let's see. There's a question here from Nirav Shah from Mumbai in Maharashtra. What will be the timeline for electronics manufacturing in India in the coming future, especially semiconductors, which is currently non-existent? So, Nirav, great question. If you think about electronics manufacturing, you've got to look at it as two very distinct ecosystems. One is the semiconductor manufacturing ecosystem, and you're right that other than Semiconductor Complex Limited and a couple of other strategic fabs that the government runs, there isn't much by way of semiconductor manufacturing that's happening in India. But when it comes to end product electronics manufacturing, that there is a fair amount of traction and growing. And we keep talking about many more global electronics product companies that are actively evaluating the opportunity of moving their production to India. There is a lot of indigenous product startups that obviously would have a preference for looking at manufacturing in India, and so there's investment in Indian EMSs or electronic manufacturing houses as well as global EMSs that are trying to establish their presence in India. So that's definitely a space where I expect there will be more traction in times to come. And if anything, the current situation should perhaps lend it a little bit more momentum and accelerate the process. Okay, let's see. Herschel Mali from Vadodara, Gujarat. How SoC is different from microprocessor or microcontroller? So this is different terminology. Microprocessor is a single chip that is dedicated towards doing a processing of various streams of data that come in. And there's a certain architecture that goes with it in terms of different things on chip cache, processing unit, et cetera, et cetera. SoC is a more generic term. It's really referred to as system on a chip. It may or may not have an embedded processor in it, but it may be targeted for a very broad range of applications. So think of SoC as a concept. It's really system on a chip. It's a chip that has got different types of functionality and can perform a broader function. And a microprocessor is a specific type of SoC if you want to look at it that way. Sai Praneeth from Rajamapeta. What about AI in the field of semiconductors? Well, I'm glad you asked that question, and I think I did address part of it in my talk. But um, AI is one of the key drivers. AI, think of AI, think of it in relation to generating large quantities of data and leveraging machine learning to process and gain actionable insights from the data to then be able to make some useful use of that data. Machine learning, as we know it today, is a key application and a key driver for the entire semiconductor industry. So, we talk of it as from a cadence standpoint, right? And in the context of our offerings, we talk about machine learning inside of our tools and how we use it to make our products better, smarter, faster. Uh, Machine learning outside, how we use the data that our customers may be generating to use that data to help them optimize and improve their design flows and design methodologies. And we talk about enabling machine learning or AI, which is when our customers are designing products that are targeted for various kinds of machine learning applications, end applications. Then how do we provide them with processor cores and design tools and methodologies that enable them to do that? So net, semiconductors is a key enabler and at the heart of this entire AI revolution. As I also mentioned, there's over 150 processor startups worldwide that are coming up with unique processor architectures that are optimized for various kinds of machine learning applications targeted for vision or audio or different kinds of data sets that get generated. So clearly, AI is really at the heart of what's driving semiconductors and electronics today, and I'm sure many years into the future. Okay, let's see. A lot of questions, and I think I'm going to run out of time. But maybe I'll make this the last question because we are coming up to 7 p.m. At the end of our time slot, maybe one or two questions really quick. This question is coming from Shivam Khare in Lucknow. Is how do we see 5G adoption in India and what can be some interesting areas to start ventures in semiconductors and embedded domain as indigenous manufacturing is being promoted under Make in India? So um, Shivam, I think I tried to give you a preview of that towards the end of my talk in terms of what are some of the areas in which to start ventures, right? Semiconductors, designing a chip is a very expensive affair and requires you to raise a large amount of funding. Typical chip requires anywhere from 10 to God knows 20, $30 million of investment, and it takes several years to design the chip, do a prototype, look at the end application, eventually go into production. So what we refer to as time to money could be as much as 5 to 7 years. So it's a long-term commitment, and it's a big boys game, meaning you need to be able to raise a large amount of funding, and to attract that funding, you need to have a truly innovative and differentiated product idea. But for the rest of electronics, as you refer to the embedded domain, I think the opportunities are many, many more for entrepreneurs in India. I gave you a preview of some of the areas where you've got, think of, look around you and observe and look at the unsolved problems of the people around you. And every problem that you observe is an opportunity if you can find a way of solving it in a sustainable, profitable manner. So lots of opportunities. And again, if you look at my Avahan talk, it gives a little bit more detail. And if you've got some exciting ideas, please write to us at the email address I gave, and maybe we can uh, initiate a sidebar conversation about that. Let me just quickly look to see if there is any other questions that we want to tackle before we call it a wrap. Uh, wow, it's lovely to see so many questions and lots of excitement around it. Okay, I'll make this the last question because I think this will resonate with many people on this call. Sohan Lal Chaudhary from Hyderabad has this question. One advice which you would like to give to an undergrad student who is willing to pursue a career in VLSI? Um, Sohan Lal, thanks for asking that question. My advice is, first of all, you should pursue a career in something that you are clearly passionate about, right? And I say that because it's my belief that work consumes 8, 10, 12 hours of every single day of our lives. And unless we love what we do and we are passionate about what we do, we will not have a fulfilling and satisfying and exciting career. And it's a very important part of what to look forward to in a career. Um, if you are, if you love this domain, if you're passionate about building a career in this domain, then definitely seek out help from your faculty and get access to tools like Cadence. Take the guidance of one of your faculty members, use those tools, try to do some projects, definitely seek out an internship, because there is nothing like actually getting your hands on to get a feel for the industry, and that will also help you get a better understanding. Those projects will make you more valuable to prospective hires, to prospective hiring companies in the future, and it will confirm whether you are indeed passionate about this field and you love this domain and you should be building a career in this domain or no. So I think that's a great note to end this talk on. Thank you all for participating in today's session. And if you have further feedback or comments, please feel free to write to me at the email address I gave, and I'll try to respond to as many as I can. Um, with that, I think we are at the end of today's session. Thank you very much.